In this video, we are going to talk about numerical integration. So we have a problem that we have to evaluate this integral y dx from 0 to 1.4 and x values and y values are given. We can look at the x values and say that this data is equally spaced because between every two consecutive x values the difference here is 0.2. For example, the difference between 0.2 and 0 is 0.2. 0.4 minus 0.2 is 0.2. So it's the same for all the data. So before we start this question, let's name the data values. So starting from 0, we will name it as x0, x1, x2, x3, x4, x5, x6, x7, and the corresponding y values will be named as y0, y1, y2, y3, y4, y5, y6, y7. And another thing that you have to do is, since the last x value is x7, so call it xn to decide what is n. When you call x7 equal to xn, this says n is equal to 7. So we have n equal to 7 and the difference between every two consecutive x values is 0.2. So we are calling age equal to 0.2. And since this data is equally spaced, and we know that in an equally spaced data, every xn can be written as x0 plus nh. Usually we use this formula to find either the value of age or n. But in this case, we already know age and n. So let's solve this integral by using the trapezoidal rule of integration. And remember that trapezoidal rule of integration works for all n. So what is the trapezoidal rule of integration? It says we can integrate y with respect to x from x0 to xn, and that would be equal to h by 2 y0 plus 2 into y1 plus y2, and it goes all the way to yn minus 1 plus yn, and you close the bracket. So this is the trapezoidal rule of integration. We have n as 7 and h as 0.2. Let's plug this in this formula. And also x0 here is 0 and xn, the last x value, which is x7, is 1.4. h is 0.2 divided by 2. y0 plus, and we will put the last value first, n is 7, so it is y7 plus, and then we will fill in for yn minus 1. N is 7, so n minus 1 will be 7 minus 1, which is 6. So we have y6, and this section ends at yn minus 1, goes all the way back to y1. So we have the last value y6 in this section, and it has to go all the way back to y1. So y5, y4, y3, y2, and y1. We close the bracket and 2 outside. Now that we have formula for our data, so let's plug in the values. y0 was 1.21, so you plug in y values from here. Plus 2, y1 is 1.37, plus y2 is 1.46, y3 is 1.59, y4 is 1.67, y5 is 2.31, y6 is 2.91. We close the bracket, plus y7 is 3.83. So we calculate this inside sum multiply this by 0.2 and divide it by 2. So we get here 2.77. So we have solved this integral y dx from 0 to 1.4 using trapezoidal rule of integration. In the next video, we are going to evaluate the integral using Simpson's 1/3 rule of integration.